Okay, so good morning, class. How are you today? Okay, it is great to hear that you are all doing good. So, everybody, I would like you to read a quote. Okay, so kindly read. Okay, and with that, may I ask everyone to kindly stand up for a prayer? Our prayer leader, please kindly lead us a prayer. Amen. Thank you for that wonderful prayer. So, as we usually do, before you take your seat, kindly check for any litters under your chairs, and if there are any, kindly pick them up and throw them in the trash can. Okay, thank you very much. You may now take your seat. Now, I would like you to tell me if any of your classmates not around. Okay, I think no one is absent. Okay, so very good, perfect attendance. I hope you can be able to maintain that perfect attendance up until the end of this semester, okay? Okay, so since we already handed our words to God, are you all now ready for our class? Okay, so thank you for that. I have here an image. I have here 4 images and I would like you to identify them. So what is the first image? Yes, exactly. Very good. It is snow. How about the second one? This image. What do you see here? Yes, very good. Rain. It is raining. So rain. Next one. What could this be? Yes, exactly. It is hail. And the last one? Yes, very good. It is sleet. Very good. You were able to remember our previous lesson. I would like you to differentiate snow, hail, sleet, and rain. Who would like to try? Okay? Excellent. Thank you for that. So snow falls when the temperature in the clouds falls below freezing, whereas rain, as we all know, is a falling liquid water. And of course, hail. This hail forms when a drop of rain freezes and a strong wind carries them into the clouds. So that is how hail forms. Now, last one is sleet. So sleet is rain that freezes as it falls. Okay, so I hope the difference of these 4 are already clear to everybody. Now, what is the general term for snow, for hail, for sleet, and for rain? Okay, very good. It is precipitation. So so we have precipitation. And today we are going to define precipitation and explain how precipitation is distributed globally, and of course enumerate the factors in the distribution of precipitation. Okay, and going back to the word precipitation, so I would like you to come and get a piece of chalk here in front and write whatever comes into your mind when you hear the word precipitation. Write words or phrases that comes into your mind when you hear the word precipitation. Who would like to try? Okay, go ahead. Okay, thank you very much for all of those who wrote on the blackboard, on our blackboard. Now, everybody, kindly bring out 1/4 sheet of paper. Does everybody have 1/4 already? Okay, so in that 1/4 sheet of paper, you are to formulate now your definition of precipitation based from the words and phrases that you hear in our blackboard. Okay, so I'm going to give you 2 minutes to formulate your definition. Write it down in your 1/4 sheet of paper. Kindly write your name and the date today. Okay, so time's up, everybody. Kindly pass your 1/4 sheet of paper. Okay, so thank you very much. Pick 3 letters, and I am going to read your answer. But don't worry, I'm not going to read your names. Okay, so the first one. Okay, very good. So next, second. Okay, let's now proceed to the second paper. Okay, excellent. So next, Okay, so I'm sure that you were able to formulate a good definition of precipitation. Now let us look at how meteorologists define precipitation. So everybody, kindly read. Okay, thank you very much. So precipitation is not just grounded to rain, okay? As most of the people know, it's not grounded to rain. Rather, a snow, hail, sleet, as we have said a while ago, are considered precipitation. Okay, rain is just the most common precipitation. Okay, take note of that. So next, I would like us to play fact or bluff. Does everybody knew the mechanics of fact or bluff game? Okay, so when I am going to show phrases or sentences about precipitation, and you are going to say if it is either fact or bluff. When you say fact, it is true. When you say bluff, it is not true. Okay, so since you are already since you are already in 4 rows, you are going to be grouped in 4. So row 1 will be group 1, row 2 will be group 2, row 3 will be group 3, and row 4 will be group 4. Okay, so you have to, so I am only going to allow you to answer once. So before you say your name, before you answered, make sure that that is already your final answer. Okay, so did everybody get it? Okay, so let's start now. So precipitation varies from place to place. Precipitation varies from place to place. Is it a fact or a bluff? Okay, so what is your answer? Okay, so it is a fact. Very good, everybody got the correct answer. Okay, so next. So the general circulation of the atmosphere, mountain ranges, and high plateaus affects the distribution of precipitation. The general circulation of the atmosphere, mountain ranges, and high plateaus affects the distribution of precipitation. Is it a fact or a bluff? Okay, so let us see if who got the correct answer. So it is the fact. Okay, so next. Precipitation is most abundant where it sinks and least abundant where it rises. Okay, I'll repeat. Precipitation is most abundant where it sinks and least abundant where it rises. Is it a fact or a bluff? Okay, let us look at your answer. Let us look at if who got the correct. And okay, so everybody, it is a bluff. Next, in the polar region, there are little moisture, so there is little precipitation. In the polar region, there are little moisture, so there are little precipitation. Is it a fact or a bluff? Okay, let us look at if you are correct. Let us see. It is a fact. Okay, so the answer is fact. Next, this is actually the last one. The wettest places in the world is located on the windward side of mountains. I repeat, the wettest place in the world is located on the windward side of mountains. It is a fact or a bluff. Okay, let us see if your answers are correct. So it is a fact. So the wettest places are located in the windward side of mountains. 1 point, group 2 got 1 point also, group 3 got 3 points, and group 4 got 2 points. So, of course, the winner is group 3. Congratulations. So let us go back to the first, phrase. So precipitation varies from place to place. So let us look at how precipitation varies from place to place. So this map shows the worldwide general pattern of the annual precipitation. So based from the map, what can we infer now about the distribution of precipitation? Who would like to try? Okay, yes. Okay, thank you for sharing your thoughts. How about the others? Yes. Okay, so thank you for those who shared their thoughts. So as we can see in this image, there are certain regions that stand out as dry and wet. So if you can observe in our tropical region, what color is most abundant? Okay, it is blue. And blue signifies that there are more precipitation, which means it is wet in that area. And Philippines, where is the Philippines? Philippines is located in the tropical region. Hence, we have wet area in this region, especially in the equatorial region. The equatorial region or the tropical region, the most color that we see are yellow and orange, which signifies that there are less precipitation. Now, why do you think is the distribution of precipitation like that? I am going to pick your names based from your 1/4 that you have given to me. So let us pick who would like to answer. Okay, so Miss, go ahead and try to answer the question, why is the distribution of precipitation like this? Kindly. Yes, very good. You have a point. Now let us look at why is the distribution of precipitation like this. Why is the equatorial region wet and the polar region, while the subtropical region up to the polar region are dry? So that is because of the factors that directly affect the distribution of precipitation. And number one, that is the general circulation of the atmosphere. The second one is, kindly read. Okay, so these are the two factors that directly influence the distribution of precipitation. So let us first look at the general circulation of the atmosphere, if you can still remember our previous lesson. Okay, so can you still remember this? So how do you call this model of the general circulation of the atmosphere? Okay, exactly, very good. This is the 3-cell model of the general circulation of the atmosphere, whereas we have our Hadley cell, our Ferrel cell, and our polar cell. Okay, and we have, of course, our intertropical convergence zone. And take note, intertropical convergence zone, is it our equator or not? Who says yes? Who says no? Okay, so very good. Intertropical convergence zone is not our equator. Rather, it is above the equator where northeastern trade winds and southeastern trade winds converge. Okay? And fishers actually call them doldrums. And in this region, L, we see L, which symbolizes that it is low pressure. So it is low pressure in this area, whereas in our North latitudes is high. In the polar area, we have high. In the polar high is high pressure, while in the polar front we have low pressure, and so as with the southern hemisphere. Okay, so we have our westerlies due to Ferrel cell, and we have northeastern trade winds, Hadley cell in our tropical regions. Okay, so take note of that. Now, how does this general circulation of the atmosphere affects precipitation? Everybody, kindly read. Okay, so precipitation is most abundant where the air rises and least abundant where the air sinks. Okay, when do air rises? Okay, very good. As so air that rises, these are warm, less dense air. Okay, so when this warm, less dense air goes up, leaving now a low pressure area. Okay, so very good. Abundant where it is. Okay, very good. And where thus air sinks? Okay, of course in the high pressure area. And the movement of air is of course from high pressure to low pressure area. So don't forget about those general principle on the movement of air. Okay, and so the precipitation, always remember that precipitation is most abundant where the air rises and least abundant where it sinks. Let's look at this simplified form of the certain regions of where air rises and air sinks. So this is simplified form of how general circulation influences the distribution of precipitation from north to south. If you can remember, our ATZ again is what? Low. It is low pressure area. Subtropical high, high pressure area. Polar front, low pressure area. Polar high is high pressure area. And the rule is air moves from high pressure area to low pressure area. So in the low pressure area, air moves up and sinks in a high pressure area. So from low pressure area, air rises and it sinks in a high pressure area. That is why, if you can see in this area, in the intertropical convergence zone, which is low pressure area, because air rises and it sinks in the high pressure area in the subtropical high. Subtropical high. Okay, so when air rises, as we can see, all seasons are wet because precipitation is most abundant where air rises. So, did everybody get it? Okay, very good. So all seasons are right. So all seasons are wet in the intertropical convergence zones. Then we have between subtropical high and intertropical convergence zone, we have wet summer and dry winter. Now, when in the subtropical high where air sinks, all seasons are dry. Okay, now between subtropical high and polar front, dry summer and wet winter. Now in the polar front, which is low pressure and air rises, all seasons are wet. And all seasons are wet. Then it sinks in the polar high, resulting now of course to seasons that are dry. Okay, did everybody get it? How the general circulation affects the distribution of precipitation. Okay, it is great that you understood it. So next, let us understand the distribution of precipitation per region. Let's first talk about our tropical region. So tropical region. May I ask a volunteer please to kindly read it? Okay, please. Okay, thank you very much. So as we have said, the tropical region, since it is the most exposed part, or we can say it receives more sunlight, using now rising air, towering clouds, and heavy precipitation all year long. Okay, all year long. That's why in the tropical region, or most especially in the equatorial zone, it is typically wet. Okay, now in the subtropical, the sinking air of the subtropical highs produces a dry belt around the globe. So the sinking air, so I will repeat, in the subtropical region, the sinking air of the subtropical highs produces a dry belt around the globe. Okay, so that is the precipitation in the tropical region and the subtropical region. So let us look at the most prominent desert in this area. So the desert is located in the north of Africa. The annual rainfall in Sahara Desert is exceedingly light, and it varies from year to year because major wind bands and pressure system shifts from season to season. For example, it is northward in July and southward in January. That is because the area between the rainy tropics here is influenced by both the ITCZ or the Intertropical Convergence Zone and our subtropical highs. Okay, so did everybody get it? Okay, so let us now look at polar region of polar in the cold air of polar region, there are little moisture, so there are little precipitation. So meaning, if there are little moisture, it results to little precipitation. Okay, as we've said, because pole, as we all know, it does not receive sunlight, does not receive more sunlight compared in the tropical region. So winter storms drop light, powdery snow that remains on the ground for a long time because of low evaporation rate. Because as I have said, polar region is not exposed to sunlight. That is why we have low evaporation rate, resulting now, of course, to little moisture and little precipitation. Okay, so in summer, a ridge of high pressure tends to block storm systems that would otherwise travel into the area. That might result, of course, precipitation. However, as we have said a while ago, polar region is high pressure. That is why it blocks, of course, the storm system that would like to enter, system that would otherwise travel into the area. Okay, so that is the precipitation in our polar region. Okay, so next let's now move on to our middle latitude. So when we say middle latitude, as we can see in our map, so this is low latitude, which comprises of our tropical region. So middle latitude is from Tropic of Cancer above the Tropic of Cancer to the Arctic Circle. So this one is our middle latitude and our southern middle latitude. So let us now look at in a map. So this is our this is our tropical region, whereas this is our middle latitude. Okay, so in this middle latitude there are more countries that belongs in the middle latitude. Okay, so in the middle latitude, kindly read. Okay, thank you very much. The migrating position of the subtropical anticyclones. Okay. Okay, so in the middle latitude, it is not only the general precipitation that affects it, rather subtropical anticyclones also contributed in the distribution of precipitation in the middle latitude. So eastern side of anticyclones tends to be more stable. It is also drier as cooler air moves equatorward. Okay, so that is the eastern side in the middle latitude. Whereas in the western side, kindly read. Okay, very good. That eastern side. So if the eastern side is more stable, in the western side it is less stable, and there are more moist, and of course warmer air moves poleward. Okay, so if you can remember, in this area we have what we call as in our general circulation, let us go back to our general circulation. So this is our mid-latitude. So if you can see, we have westerlies. Okay, so the movement of air, is west to east. That the air in the mid-latitude is what we call as westerlies due to the feral cell. Okay, that is why their air is less stable and more moist as warmer air moves poleward. Okay, so that is in our middle latitude. Hence, okay, cities on the plains, when I say plains, these are large flat areas, okay, these are flat areas. Cities on the plains typically receive more rainfall in summer. And as cities on the west coast have maximum precipitation in winter, say maximum, of course, more precipitation in winter, while cities in the Midwest and East usually have abundant precipitation all year long. Okay, so in the West, it has maximum precipitation during winter, while in the plains, we have more rainfall during summer. But in the Midwest and East, while cities in the Midwest and East have abundant precipitation all year long. There are no specific season, rather it is all year long. Okay, so let us look at these three cities as our example. We have San Francisco, Kansas, and Baltimore. So San Francisco, as you can see in the map, is located here, is located in the West Coast area. This is a West Coast city, whereas Kansas is located, as you can see, in the Central Plain. And we have Baltimore, which is located in the East Coast. It is a city located in the East Coast, which is Baltimore. If you can, so I want you to observe this one. This is a graph of their precipitation all throughout the year. So this JFMAMJJASM. So below this is actually the months. We have January, February, March, April, May, June, July, August, September, October, November, December, all throughout. And this is the severeness of how often precipitation occurs in there. So, as you can see in San Francisco, in the West Coast, what do you observe? So, precipitation maximum in winter. So, winter season, we have, of course, as you can see, we have December and January has the highest precipitation. Okay, but when it comes to summer, it is decreasing. So the amount of precipitation is decreasing when it comes to summer. During summer, okay? So precipitation is maximum during winter in the West Coast cities. Okay? Let's now move on to, let's look at the Central Coast, meaning the Central Plain city, Kansas. So as you can see, the graph of San Francisco and Kansas are so much different. The highest is during summer. Okay, because precipitation maximum in summer. During summer, there are more precipitation in Kansas City. It reaches the maximum precipitation. So as you can see, if in San Francisco the highest is during December and January, Kansas the highest precipitation is during May and June. Okay, so I hope you were able to see the difference between West Coast cities and the Central Plain cities. Let's now move on to the last city in the East Coast. We have Baltimore. So in Baltimore, unlike Kansas and San Francisco, it changes from month to month, but it does not go down severely just like Kansas or San Francisco, but precipitation is abundant all year long. So precipitation, unlike Kansas City and San Francisco, Baltimore has a maximum precipitation all year long. It is not only during winter or summer, rather it is all year long. Okay, and the highest is during the month of April. Okay, so that is how the general circulation of the atmosphere affect the distribution of precipitation. Okay, so let us now move on to the next factor. What is it again, if you can remember? Okay, very good. Mountains and high plateaus. Okay, so next that affects the distribution of precipitation is mountain ranges and high plateaus by promoting convection. Okay, how? How do you think that mountain ranges promotes convection? Anyone? So what is the characteristic of air in the mountains? So mountain ranges promotes convection because their slopes are warmer than the surrounding air. That is why they promote convection. Okay? Is mountain ranges disrupt the idealized pattern of global precipitation by forcing air to rise along their windward slopes. Okay, so let us look at the windward and leeward side of mountains. And how does it affect? So based from the image, I would like you to describe the windward side of mountains and the leeward side of mountains. Okay, so I'm going to pick who will be the one to describe the leeward and the windward side of mountains. Okay, we have Miss. Okay, kindly. Okay, thank you very much. Okay, very good. It is indeed. So as you have said, windward, we already have it here, is wet. Leeward is dry. Why? So as you can see, windward, this is the area of the mountain which faces oceans or body of water, whereas cooling where most rain occur. Okay, because as the moist air ascends, it results to a more rain, more precipitation. Okay, because there are more moist, as we have said, if there are more moist, there are more precipitation. As the air descends and warms along the leeward side, there is less likelihood for the creation of clouds and precipitation because we have said it is already dry. It is now termed as rain shadow. We have here a much more clearer classic example. So this shows a classic example of how topography produces rain shadow. So what is rain shadow again? Okay, this is the leeward side of the mountains, which is literally dry. So as you can see, this is a coast range mountains. We have Santa Cruz, these are the places, San Jose, Mount Hamilton, Los Baños, Merced, Mariposa, Yosemite, Ranger Station, and we have Bishop, then Tonopah and Nevada. So this is Sierra Nevada. And so this is the windward side and this is the leeward side. So this is how topography affects the distribution of precipitation. So always remember that most of the rainiest places in the world are located on the windward side of mountains. Okay? Okay? And these are the examples, like we have Hawaii has the greatest annual average rainfall on the record, which is amounting to 1,168 centimeter. Okay, so always remember that the wettest place are located in the windward side of the mountains. It's not on the leeward side. Okay, so that is the general annual distribution of precipitation. Okay, so now I would like everybody to kindly bring out one half crosswise, and I would like you to copy and fill in the blank. Okay, copy the items and fill in the blank. Okay, we're not just going to write your answer, you are going to copy the sentences provided in here and your answers. Okay, I am going to give you 15 seconds, 15 minutes to answer our activity. Okay? Okay, so time's up. May I ask everybody to kindly pass now your papers? Okay, thank you very much. So, for your task, I would like you to work with your seatmate. Okay, work with your seatmate and create an infographic about precipitation. Okay, this is the rubrics for your activity. So we have content and creativity. So all the needed, if you want to have 50 points, all the needed content are present accurately and are organized. Definition of precipitation, the factors affecting the degree of precipitation. Of course, include precautionary measures before, during, and after a certain precipitation. Okay, and of course, the infographic reflects an extensive use of technology, which means you were able to use the features of that certain platform. Don't worry, I'm going to give you a copy of your rubrics so that you'll be guided on how you are going to create your infographic. Okay? So the deadline will be this. So the deadline will be the end of this week. Okay? It is not already time yet. I would like you to talk with your self-mate and plan on what you are going to do about your infographic. Okay? Okay, so it's already time. May I ask everybody to let's stand up for a closing prayer. Prayer leader, please. Okay, thank you very much. So once again, my dear students, thank you for your active participation again for today's lesson. So don't forget about your class. Okay, that's all for today. Goodbye, class.